Examples of dative covalence. Kind greetings to you all. I welcome you all to Mwalimu Education Services. This video is suitable for students in Senior 5 and Senior 6 who are offering chemistry as part of their subject combinations. Kindly, if you do not fall under the mentioned categories, explore through the channel, explore content which has been uploaded here to find material which best aligns with your level. So, formation of examples of dative covalence we have. The first one is formation of ammonium ion. Formation of ammonium ion. Ammonium ion is NH4 with a plus. Yeah. Now, to form the ammonium ion, the good thing is that we have seen. Now, when you look through your material, look through the material which you have, the preceding information which we have so far covered, you see that we formed ammonia. We illustrated how ammonia is formed. So ammonium ions come from ammonium ions come from ammonia, which is NH3 plus hydrogen ion from ammonium ion. Yeah, it is formed from that combination. Now, we have seen how ammonia is formed. Look through your book very well. Check for that example, formation of covalent bonds. There is that example which you have that shows how ammonia is formed. Now, from that example, you will see that this is how we represented ammonia. After drawing those things of what? Those electronic diagrams. This is what we formed as ammonia. And that ammonia which was formed was having dots on nitrogen. Those dots on nitrogen, they are known as lone pairs of electrons. Yeah, and I remember explaining them in class that they are called lone pairs because they are lonely. They are not participating in bonding. Yeah, so they are there. So meaning that here, since nitrogen has lone pairs of electrons, it is electron rich. Yeah, it is electron rich. So look at that thing, that electronic structure of ammonia. Then for hydrogen itself, this is hydrogen ion, not hydrogen. Hydrogen itself is 1s1. Hydrogen itself is 1s1. But its ion, the hydrogen ion is 1s0. It has electronic configuration 1s0. So meaning that we have an empty orbital. You see, you have an empty orbital for hydrogen ion. Hydrogen ion has no electrons. So it is an empty space, a space without electrons. So this is H plus, meaning that in this case we have hydrogen ion, which is don't worry, you should put all these things in your work, yeah, so that you understand this better. So if I don't know, some of you may think that if I make if I make those branches, then I am making the worker disorganized. The work of scientists is not always organized. That's what I can tell you. It is not always organized. Okay, so I'm going to make those minor writings promptly. So the hydrogen ion in this case is the acceptor species. Acceptor species because it has empty space. It has empty space or vacant orbitals. Then I'm saying that this nitrogen within ammonia is the donor species. So I'm saying that N here is the donor donor species. Why? You have been able to look at that structure which was made in class, and you have convinced yourself that nitrogen has those lone pairs of electrons. Yeah, the ones that are not used. Look at the outermost shell of nitrogen. Those electrons that are left that are not used, they are the ones which I'm calling lone pairs of electrons. So since they are there, this makes nitrogen to become the donor species. Donor species because it has lone pairs. It has lone pairs of electrons. Lone pairs of electrons. So meaning that since nitrogen is electron rich, it is going to donate these electrons to hydrogen, that is electron deficient. So after donation, what do we form? We form N. N was previously carrying 3 hydrogens like that. Now I am bonding this N with another hydrogen, and we are forming a dative bond. I have said that a dative bond is represented by a horizontal arrow coming from the donor to the acceptor. The donor in this case is N. So that's why we have an arrow coming from N to H. Yeah, and this is an ion. So we shall have closed brackets and a plus here up. So this arrow here is the arrow, the dative bond. Another example, formation of hydronium ion. Formation of hydroxonium ion. This is the ion represented by H3O+. Where does it come from? It comes from water. It comes from water. Water is H2O. It comes from water, which is H2O, then plus hydrogen ion. Hydrogen ion, H+, like that. So what do we form? We form hydronium ion, H3O+. That. So we were also able to, when you look at the material which you have in your books, look at the material which you have in your books, we are able to draw the structure of water. So look at that structure of water, you'll see that this is how it was looking like. Oxygen was having lone pairs of electrons. Yeah. Those lone pairs of electrons, look at the outermost shell of oxygen. Review that information where you have the structure of water molecule, formation and the formation of covalent bonds. Now, when you look at the outermost shell of electrons for oxygen, you'll see that because there are 6 electrons there. 1, 2, 3, 4, 5, 6. Now, this bonds with the hydrogen. This also bonds with the hydrogen. You see? So this is OH. Yeah, maybe for purposes of clarity, let me also put it here so that I give you a strong, very strong intuition. Alternatively, from our electronic structures, oxygen has how many electrons in the outermost shell? There are 6. 1, 2, 3, 4, 5, 6, like that. Now, these ones that are not paired, they are the ones that go with hydrogen. So we have H here and H there. Then inside here we have O. So you see, now these electrons here up, those are the ones which I'm calling lone pairs of electrons. The electrons are lonely, and I want to say that since they are lonely, they are not participating in bonding. Then hydrogen ion, what does this mean? In this case, it implies that here is where we have the donor species. Why am I calling it the donor species? Because it has lone pairs. It has lone pairs of electrons. It has lone pairs of electrons. Then the hydrogen ion, I want to say that hydrogen itself is 1s1. Hydrogen as an atom, 1s1, but as an ion, it has already lost 1 electron. So it has empty space. So here we have H plus. H plus with the, note it has electronic configuration 1s0. So 1s0, meaning that this is acceptor what? Acceptor species. Acceptor species because it has empty space. It has empty space or vacant orbitals. Vacant orbitals. So what does this imply, colleagues? It implies that we shall get lone pairs of electrons from oxygen and donate them to hydrogen, like that. Donate them to hydrogen. So what do we form after that donation? We shall form O is carrying two hydrogens. Now this O, I am bonding it with the H, like that. We represent a dative bond by an arrow coming from the donor to the acceptor. So this arrow shows a dative bond. As for now, allow me stop here. And in the next session, we are going to look at the other interesting things